Calculus, lesson P5, factoring polynomials. In the last lesson, we talked about how we could, in this case, talk about polynomials and do operations with polynomials. So why don't you pause the video right now and take a second to work through these three problems. I'm going to go ahead and go through these three fairly quick, but notice in this very first one here, what we wanted to do was actually do the subtraction. So when we're subtracting polynomials, remember we're distributing that negative to every term in the second polynomial, changing their signs. And then from there, this is where addition is the same, we can combine like terms. So in this first problem here, we should have got, after combining like terms, 5x cubed plus 7x squared plus 6x minus 7. In the second warm-up problem here, this is where we were multiplying two polynomials. This means that we need to distribute every term in the first polynomial to every term in the second polynomial. And so if we do that, in this case, go ahead and distribute the 2x to everything, and distribute the 9y to everything, and then the negative 5 to every term in that second polynomial. And if we combine like terms, we'll notice that some of the terms we were able to combine, but some terms are just going to cancel each other out. And so our final answer here in two variables was 4x squared plus 36xy plus 81y squared minus 25. Notice here the degree of this polynomial is 2 because the highest degree of any term is 2. In the last one here, I chose to FOIL, but you might be able to recognize this as a special case, which was a product of a sum and difference of the same term. So in this case, remember, that always resulted in the square of the first term, or 9 squared, which is 81, minus the square of the second term, in this case, y to the 4th, which in this case would be y to the 8th. If you chose to FOIL, you'll notice that those middle terms do cancel out, and you end up with the exact same solution. Today we're going to be working backwards here from the opposite of FOILing. In this case, we're going to be working with factoring. So our very first method to do with factoring is always going to be the greatest common factor, which is abbreviated GCF. It is the expression of the highest degree that divides each term of the polynomial. So like in this very first case, what we want to do here is we have two terms of binomial. You'll notice that we have 10x cubed minus 4x squared. Both 10 and 4 are divisible by 2. And since there is an x cubed and x squared, the highest number of x's we can take out is the x squared. So our GCF is 2x squared. And so when factoring, we're always going to write that GCF first, and then inside the set of parentheses, we're going to write what would remain if we divided both terms by that GCF. So in this case, if we took out a 2x squared from 10x cubed, well, 10 divided by 2 is 5. And we take away if we take away 2 x's, the x squared, we'll be left with 1, just x. In the second term, if we divide the negative 4 by 2, we get a negative 2. And since we are taking out an x squared, there's no x's remain, so it's just 2. So our factored form here would be 2x squared times the factor 5x minus 2. In the second one here, we still only have two terms, the 2x times x minus 7 and the 3 times x minus 7. It is possible for the GCF to be a binomial as such, in this case, the x minus 7. And so what we're going to do here is we're going to take an x minus 7 out of both terms. So we can rewrite this by factoring by putting our GCF first, the x minus 7, and then write what would remain. In this case, the 2x from the first term and the plus 3 from the second term. So our two factors here will be x minus 7 and 2x plus 3. Notice we cannot go any further with this because in both factors, there's not anything else that we can take out of it. In the case that we cannot take out a greatest common factor, then what we want to do here is we're going to try grouping if there are 4 terms in the polynomial we're asked to factor. In this case, what we're going to do is we're going to start by grouping the first two terms of the polynomial together, and then also the second two terms of the polynomial together. So if we look at the first two terms, we have x cubed plus 5x squared. And we will note here that if we do this, that we get a GCF out of x squared, because that's what we can take out of both those terms. By taking out the x squared, we're left with an x plus 5. In the second two terms, the most we can take out of both terms is a 2. Since we want what's in the parentheses to match, in this case we need to make sure that we're taking out a negative 2. So if I take a negative 2 out of the negative 2x, that leaves us with a positive x. If I take a negative 2 out of the negative 10, that leaves us with a positive 5. Notice now in the step that what's in the parentheses looks the exact same. If we look in our two terms then, we notice that we can do exactly what we did with our last problem with the GCF. The GCF between both these two terms is the x plus 5, and our other factor then is just going to be what remains. In this case, the x squared minus 2, which means the factored form here by grouping would be x plus 5, x squared minus 2. Now, in the warm-up, in the very last example, we looked at the example of the product of a sum and difference. And that always resulted in the square of the first minus the square of the second term. In this case, if we can reverse that, and this is what we call the difference of squares. This means that if we see a if we see a binomial then has a square something that we can square root in the first term and square root in the second term, then this will automatically break apart into a plus b and a minus b. For example here, notice in this example we have a binomial that we are subtracting, a difference. If we look at the first term, we notice that in this case that we get 36x squared, which we can square root. And then in the second one is 25, which we can also square root. So we can rewrite this as 6x squared minus 5 squared. And so this is a difference of squares, which means we can rewrite our factors as 6x minus 5 and 6x plus 5. Another way of thinking it as the square root of each term, but with a difference in signs. Similarly here, notice that is a difference, and we can square root both terms. In this case, the square root of 81x to the fourth is 9x squared, and the square root of 16 is 4. So we can rewrite this using our difference of squares pattern as the two factors, 9x squared minus 4 and 9x squared plus 4. But then, if we look at both of these two terms, we notice that the 9x squared minus 4, we can actually go ahead and square root both of those. And this is another difference of squares. So we can rewrite this as 3x squared minus 2 squared. And so since those are both square roots, we can go ahead and further factor that down into, by splitting that 9x squared minus 4 into the two factors, 3x minus 2 and 3x plus 2. And then we're just going to bring down that last factor of 9x squared plus 4. In this case, this one cannot be broken down because it is a sum, not a difference. So this right here would be our final factored form. Now, in the case where we don't have 4 terms or 2 terms, the most common type of polynomials that we're asked to factor are trinomials. There are really 2 tiers to trinomials that we factor. In tier 1, in this case, what we get here is we have the trinomials ax squared plus bx plus c, where the coefficient a on the x squared term is 1. So for example, if we look at this trinomial, x squared plus 5x plus 6, well, notice here that the coefficient a is 1. And so what you've learned before in the past with algebra 2 that sometimes you've heard of this being called the AC method or the diamond method, but what we're looking for here are to factor this, we want two numbers that will multiply to the C, or in this case 6, but will add to the B term, 5. And so we want to multiply to 6 and add to 5. In this case, those two numbers are going to be a positive 3 and a positive 2, because 3 times 2 is 6, and 3 plus 2 is 5. Once we have found those numbers, we can go ahead and split those into our two factors of our polynomial. In this case, x plus 3, x plus 2. And that right there is going to be our final answer. We can always check that we have the correct answer by FOILing this together or using distribution to make sure it equals the polynomial that we're given. In the case, though, where a is not equal to 1, this is where we get into tier 2. It's very similar to the tier 1 trinomial factoring, but in this case we have to add one extra step. So for this first example here, if we look at number 6, we notice that we're given an a value of 3, a b value of -2, and a c value of -5. So we're going to go ahead and set up our factoring in the exact same method, but in this case, we're going to do it by multiplying the a times c. In this case, a times c, or 3 times -5, is going to give us -15. So we want two numbers, in this case, that will multiply to that -15, and then add to our b term of -2. Well, -15 and 1 do multiply to -15, but they do not add to -2. So sometimes we have to use guess and check to find the right numbers. In this case, we could also try -5 and 3. -5 times 3 is -15, and they do add to -2. So those are going to be the two numbers that we need to use. In this case, instead of just rewriting them as our factors, though, what we're going to do is rewrite the original polynomial. But instead of the middle term, we're going to use the two numbers that we found. In this case, the -5 and the +3, using the x values or whatever the variable the middle term is. From here, then, what we're going to do is we're going to use grouping. So if we put the first two terms together and the second two terms together, we can go ahead and GCF out an x out of the first two terms, giving us an x times 3x minus 5. And then on the second two terms, all we can take out is a +1, which leaves us with a 3x minus 5. Meaning here that our two factors for this polynomial would be the GCF of 3x minus 5 and the other factor of x plus 1. Let's try this again with another example. In this case, our a value is 9, and our b value is 5, and the c value is -4. So we need two numbers that would multiply to -36, which is the 9 times -4, but would add to our middle term of b, which is 5. In this case, we know that 9 times 4 is 36, and they have a difference of 5. But to make sure that they multiply to a -36, we need to make sure that we get one of those to be negative. In this case, we need to have a -4 since the 5 is positive. So we're going to replace our middle term with the two numbers we found. In this case, 9x squared plus 9x minus 4x minus 4. And then we're going to continue with our grouping. So in this case, if we look at the first two terms, we notice that we can pull out a 9x. This will leave us with an x plus 1 in the first two terms. And then in the second two terms, we can pull out a -4, which leaves us with an x plus 1. So from here, our two factors then will give us what we pulled out, in this case, the 9x minus 4. And then our second factor will be what's left over, in this case, the x plus 1. And so the factored form here for number 7 is going to be 9x minus 4 times x plus 1. In this third example, we're given an a value of 2, a b value of 5, and so our c value of -3. So our a times c here is going to be -6. Sometimes I write it as a times c. So we need those two numbers that will multiply to -6 but add to 5. Notice here, 3 times negative 2 does multiply to negative 6, but do not add to 5. So in this case, those are not going to be our numbers, so we need to try a different set. Well, 6 times a negative 1 is negative 6, and they add to 5. So our two numbers here are going to be 6 and negative 1. So from here, we can go ahead and replace our middle term with those two numbers that we found. So we get 2x squared plus 6x minus x minus 3, and we can continue with our grouping. In the first case, we can pull out a 2x, which leaves us with an x plus 3. And in the second two terms, the most we can pull out is a negative 1, because we need to keep that 3 a positive so it matches our other set of parentheses. So in this case then, our two factors will be what was pulled out, the 2x minus 1, and what's left over, the x plus 3. Again, we can check this by FOILing this if necessary. Our last example is going to be a little bit different since it is in two variables. If you notice, we have an x and a y. But we can still use this two-tier factoring method with trinomials to do the exact same thing. So notice here our a value is 8, the b value is negative 10, and the c value is negative 3. So using the a times c, we get negative 24. So we need two numbers that multiply negative 24, but add to negative 10. In this case, well, 12 times 2 is negative 24, and that also adds to negative 10. So our two numbers here are going to be negative 12 and a positive 2. We can then take those two numbers and replace our middle term with those. In this case, we get the 8x squared minus 12xy plus 2xy minus 3y squared. Notice that middle term, those two middle terms are to have both variables, the same variables as the original middle term in the polynomial. From here, we can continue with our grouping. So if we put the first two together, we notice that the most we can take out is a 4x, which will leave us with an x minus 3y. If we look at, oh, nope, made a mistake. Actually, we can take, that'd be a 2x minus 3y there. Sorry about that. And then next two, we can take out just a y only, leaving us with 2x minus 3y. Notice since they are the same, that means that we have factored correctly. So our two factors here will be 4x plus y times 2x minus 3y. Again, we could FOIL this to check our work if necessary. But factoring in a polynomial in two variables is the same as working with just one variable.